Welcome back. Today we'll solve this three-mesh circuit using Kirchhoff's voltage law. Our goal is to find the current through the 3R resistor, step by step. Let's get started. Our first step is to identify the three meshes. We'll assign clockwise mesh currents I1, I2, and I3 to each loop. These assumed directions will help us apply Kirchhoff's voltage law consistently. Now let's apply Kirchhoff's voltage law to mesh 1. We start with a 10-volt source, then subtract the voltage drops across the 2-ohm resistor and the shared 2-ohm resistor. After simplifying, we obtain our first equation. Now let's apply Kirchhoff's voltage law to mesh 2. The 3-ohm resistor belongs only to this mesh. The 2-ohm and 1-ohm resistors are shared with the neighboring meshes. After simplifying, we obtain our second equation. Finally, let's apply Kirchhoff's voltage law to mesh 3. We include the voltage drop across the 1-ohm resistor, the shared 1-ohm resistor, and the 6-volt source. After simplifying, we obtain our third equation. Now solve all three equations simultaneously in the scientific calculator. We get I1 equals 3.65 amp, 31 amps, and I3 equals negative 1.85 amps. The negative sign simply tells us that I3 actually flows opposite to our assumed clockwise direction. And here's our final answer. The current flowing through the 3-ohm resistor is I2 2.31 amperes. Since the 3-ohm resistor belongs only to mesh 2, its current is simply I2. Great job completing this three-mesh KVL problem. Excellent work today! You learned how to solve a simple circuit using Kirchhoff voltage law, step by step. Keep practicing to build your confidence. If you enjoyed this lesson, don't forget to like, subscribe, and join me for more exciting electrical engineering tutorials. See you in the next lesson!
The adventure isn't over yet! Subscribe to MindSpark Tunes for more amazing stories, history, and learning adventures. See you next time!